Alright, this is the fourth and final video for this week. You're going to be putting everything together today and solving multi-step equations all types, including those special cases that you covered in the last lesson. So today you should be able to solve a multi-step equation and determine if the equation has one solution, infinite solutions, or no solution. Please get a multi-step equations graphic organizer from the folder and label it multi-step equations all types. Specifically, make sure that you include the words all types, please. All right, we are ready to begin here. So just a quick review as what we have had for our possible types of solutions this week. Some multi-step equations are going to have one solution, meaning there's only one number that meets the expectation of that equation. For example, we end with x equal to 0, g equal to 5. It could be, x equals -3. Any number on the number line, including fractions, decimals, whole numbers, but as long as it's equal to one number, that is considered a one solution equation. We also have our multi-step equations that end up with infinite solutions, meaning that every single number works in that equation. There are infinite number of solutions. So for example, in your work, you will end up with a number equal to itself. That tells you it's a true statement. So like 8 equals 8, that's true, so that means all solutions. The variables will cancel out, and then you'll get two numbers equal to itself. So 10 equals 10, -15 equals -15, and so on. The third and final type of solution is no solution, and that would be where there is no number that works for the equation. In your work, you will end with a statement that is not true. So for example, if you have the variable cancel out and you end up with 4 equal to 2, that is not a true statement, and therefore there is no solution to that equation. -3 equal 10, 21 equal 54, and so on. Any statement that you get that is not a true statement means there will be no solution. So we want to keep that in mind here as we continue on in our work for solving these. But remember, as we continue to solve these multi-step equations, we want to make sure to isolate the variables. We want to get that variable by itself using the inverse operations, and also making sure that whatever we do to one side, we do to the other side. This should be common sense by now, as you've practiced this many times. So let's also remind ourselves, as we solve these multi-step equations, our steps that we want to go through are: we want to get rid of the parentheses if we have any. We want to combine like terms. We want to move all of the variables to one side, move the constants or the other numbers to the other side, and then solve for the variable that we are trying to find. So I'm going to go through a couple of examples here, showing you whether there's one solution, many solutions, or no solution. Please copy these down on your paper as I go through these problems. So looking at example 1 here, I'm first going to draw my line to make sure that I understand the two different sides of my equation. And if I think about those steps, I do see parentheses. So I first want to simplify getting rid of those parentheses. So I have -7 plus, this would be -40 n plus 24. Please remember to be distributing to both of those things in the parentheses. Equals 17 plus n. Okay, so now that the parentheses are gone, and on a side note here, these parentheses are just to show that that is a negative. You could write -40n if you want to do that without the parentheses. But as I continue here, now I want to combine like terms. So on the left-hand side of my equation, I see that I can put negative 7 and 24 together. So if I do that, I would be subtracting those, and I would get 17, and then I still have the negative 40n. I'm going to write minus 40n equals. On the right-hand side, there is nothing to combine there, so that continues as 17 plus n. So now I'm going to get my variable of n all to one side, so I'm going to subtract n from the right-hand side. That cancels. I'm going to subtract n on the left-hand side here, and I have 17 minus 41n equal to 17. Now that my variables are all together, I'm going to get my other numbers on the other side. So I need to subtract 17 on the left here, subtract 17 on the right, and I get negative 41n equal to 0. Now, if I take a look at this, many students get in such a quick habit of saying, oh, that doesn't work. There's no answer. This is no solution. Okay, but if I think about still isolating that variable, I'm going to divide by negative 41 on both sides, and I get n equal to 0. 0 divided by anything is 0. Okay, so this is a one solution equation. The solution is 0. 0 is the only number that works in this equation. Okay, so that is my final answer. If I go to check that, I'm going to sub that into the original equation, and it needs to be true. So negative 7 plus 8 times negative 5 times 0 plus 3 equals 17 plus 0. Okay, so let's see. That would be negative 7 plus 8 times, let's see, negative 5 times 0 is 0. 0 plus 3 is 3 equals 17 plus 0. Negative 7 plus 24 needs to equal 17. Negative 7 plus 24 is 17. So because I get a true statement, I know that n equals 0 is correct. All right, let's go ahead and move on here to example number 2. Finding out whether this has one solution, many solutions, or no solution. So I'm going to draw that line, make sure that I keep my two sides equal. Now when I take a look here at example number 2, I notice that there are parentheses, so I want to start by getting rid of those. And if I remember here, this negative outside means that there is a negative 1. So I'm going to take negative 1 times a, negative 1 times negative 8. So negative 1 times a is negative a. Negative 1 times negative 8 is actually a positive 8. So negative a plus 8 equals 8 minus a. Okay, so I'm going to first get my variable to the left-hand side here. I'm going to add a to both sides. When I do that, on the right-hand side, those cancel. And I'm left with 8. On the left-hand side, they also cancel, so I am left with 8. Now that my variable has completely canceled out, I am left with the equation 8 equals 8. And that actually is a true statement. So my solution is infinite solutions. Any single number will work here for a. So I don't just want to leave 8 equals 8. Okay, that is good work to be shown, but I need to make sure that I write infinite solutions or many solutions, so that my teacher knows that I'm well aware of what that means. Okay, so any number that I would pick for a would actually work in that equation and make that a true statement, since the a's do cancel out. Okay, so this multi-step equation has infinite solutions, again meaning every single number that I sub in will work for that equation. All right, let's take a look here at the third and final example. Okay, we want to draw our line here to make sure we keep our two sides equal. I again have parentheses, so I want to make sure I distribute that 4 to the n and to the negative 6 to get rid of those parentheses. So that would give me 4n minus 24 plus 2 equal to negative 30 plus 4n. Now I want to combine like terms. So on the left-hand side here, I see that I have a negative 24 plus 2, which gives me negative 22, and I still have this 4n, so 4n minus 22 equals. On the right-hand side, I do not see any like terms, so I'm just going to write that down again. So I have negative 30 plus 4n. Now I want to get my variable to one side, so I'm going to get my variable to the left-hand side. So on the right-hand side, to cancel that out, I need to subtract 4n. So I do that as well on the left-hand side. On the left-hand side, 4n minus 4n does cancel out, and I am left with negative 22 equals negative 30. When I take a look at this equation, this is not a true statement. So because the variables have canceled out and I am left with something that is not true, this means that there is no solution. No number that I would pick would work for this equation. Not zero, not a fraction, not a decimal, not any whole number, positive or negative. So again, because this is not a true statement, my answer is no solution. And again, please make sure you do not just leave the negative 22 equal to negative 30. Yes, that shows that there's not a solution, but you need to write down no solution when you get something like that. All right, hopefully these three examples have helped you review our types of solutions that we've covered this week. And please take the time to pause the video, write these 4 questions down, solve them on your own, take your time, and when you are ready to go through the work and the answers, go ahead and play the video again to show, how you did on these 4. So, go ahead and work those out, and then you can check your answers. All right, let's go ahead and take a look here at the first 2 that you should have solved on your own. On the first one here, I'm going to draw that line so that I can, again, remember to keep both sides equal. I'm going to distribute on the left-hand side that negative 3 to the a and to the negative 5. So I have negative 3a plus 15 equals negative 8a minus 15. All right, so my parentheses are gone. If I look at combining like terms, I don't have anything on the left-hand side to combine and nothing on the right-hand side to combine. So I can work at getting my variable to the left-hand side and my numbers to the right-hand side to solve for that variable. So on the right-hand side here, I'm going to add 8a to cancel that out. I'm going to do that on the left-hand side as well. I'm going to add 8a. So negative 3 plus 8 is 5a. I still have plus 15 equals negative 15. Okay, so my variables did not cancel out this time. So I'm still solving for a. So I need to get the numbers to the right-hand side. So subtract 15 from the left-hand side and subtract 15 from the right-hand side. On the left-hand side, I have 5a equal to negative 15 minus 15. They're both negative, so I'm going to add them, and that gives me negative 30. Okay, well now I need to divide by 5, and a equals negative 6. Okay, so my answer is a equals negative 6. If I go to check that here, I need to get a true statement when I sub that back into the original equation. So negative 3, parentheses, negative 6 minus 5 equals negative 8 times negative 6 minus 15. So negative 6 minus 5 is negative 11. So this would be negative 3 times negative 11. And on the right-hand side, negative 8 times negative 6 is 48. And that'd be minus 15. Well, negative 3 times negative 11 is 33. And 48 minus 15 is 33. So because I get that true statement when I sub that in, I know that this is my answer. All right, on to number 2 here. You should have drawn your line, gotten rid of those parentheses by distributing that negative 3 to the n and to the 4. So on the left-hand side, negative 12 minus 6n stays there. There's nothing to combine. On the right-hand side, negative 3n, this would be minus 3n minus 12. Okay? So again, on the left-hand side, nothing to combine. On the right-hand side, I see that I have a negative 3n and a negative 3n that I can combine, and that equals negative 6n. I still have that minus 12. On the left-hand side, I have negative 12 minus 6n. Okay, so if I take a look at this, I know that I need to get my variable on the left-hand side and then my numbers on the right-hand side to solve for n. So I'm going to add 6n to the right-hand side to cancel that out. Add 6n to the left-hand side. That also cancels out. So I am left with negative 12 equal to negative 12, which is a true statement. Therefore, this one is infinite solutions. Again, meaning that any number that I pick will work in that equation. All right, let's go ahead and take a look here at number 3 and 4 before you get another set of problems to practice on your own. On number 3 here, I'm going to go ahead and draw that line. I see that I have parentheses on the left-hand side, so I want to distribute that 6 to the parentheses to get rid of that. So 6 times 1 is 6. 6 times 8k is 48k. So I have 6 plus 48k, and then that minus 5 stays the same. On the right-hand side, I have 1 minus 6k. Nothing changed there. There's no parentheses. Now I want to see if I can combine like terms. So on the left-hand side, I have 6 and a negative 5 that I can combine. That equals 1. So I have 48k plus 1 equal to 1 minus 6k. All right. I do not have any like terms on the right-hand side, so I'm going to work at getting my variable to the left-hand side. So I'm going to add 6k to both sides. If I do that, on the right-hand side, they cancel out. And on the left-hand side, I have 54k plus 1 equals 1. Okay, I'm going to subtract 1 from the left-hand side to cancel that out. Subtract 1 on the right. That also cancels out, so that makes 0. So 54k equals 0. I'm going to divide by 54 to get k by itself, and k equals 0. 0 divided by anything is 0. So this is a one solution equation where 0 is the only number that works. So if I were to sub 0 back in here, I'm going to check that. It would be 6 and 1 plus 0, because 8 times 0 is 0. Minus 5 would have to equal 1 minus 0. Well, 1 plus 0 over here is 1, so 6 times 1 is 6. 6 minus 5 is 1. 1 minus 0 is 1. So because this is a true statement, k equals 0 is correct. All right, our fourth and final problem here before you move on. Go ahead and make sure that you've done these correctly. I'm going to get rid of those parentheses again. So that negative 2 is what's getting distributed to the r and to the negative 6. So on the left-hand side here, I have 5 minus 2r plus 12. I have a negative 2 times negative 6, which makes a positive 12. On the right-hand side here, I still have 20 minus 2r. All right, let's see if we can combine anything. If I take a look here, I have 5 and 12. I can combine that to make 17. So I now have negative 2r plus 17 equal to 20 minus 2r. Alright, now that there's no other like terms, I'm going to move my variable from the right-hand side to the left-hand side. So I'm going to add 2r to cancel that out. And so I'm going to add 2r on the left-hand side. That also cancels out. Negative 2 plus 2 is 0, so that's gone. I am left with 17 equals 20, which is not a true statement. Therefore, there is no solution that would work in this equation. Again, please make sure you write no solution if that is the case. Alright, if you have any questions about those 4 problems, please see your teacher before you work on the next set by yourself. Go ahead and take a look at these next 4. You're going to want to copy them down, pause the video, go through your work, and once you have completed these problems, you can go ahead and get them checked by your teacher. Okay, and once you have them checked, you can decide whether you work on the level 4 questions that are optional, or if you work on extra practice from your teacher, or go back to a different video and work on any of those level 4 questions, since this is the 4th and final video for this week. Okay, so here are the level 4 questions that you would want to try. Again, still going through the same steps, but adding in that work with fractions. So you're still wanting to distribute, combine like terms, get your variable on the left-hand side, get your number on the right-hand side, and solve for that variable. Okay? These can also be checked by your teacher. If you have any questions, let them know. So, again, please attempt them to challenge yourself if you are done with all 4 videos and you have nothing else to do. That would be a great way to challenge yourself and be ready to be working with those fractions for algebra. If you choose not to, please make sure you turn the graphic organizer into the bin or the folder so that your teacher can record that and look at that. So hopefully now you are able to solve multi-step equations of all types and determining whether that has one solution, infinite solutions, or no solutions.